Welcome guys. We have another question here based on nth derivative. So the first question here says that we should find the nth derivative of y equals to 1 over x squared plus 5x plus 6. So in order to give solution to this, we start by saying that, let's consider the first question. Here the first question says y is equals to 1 over x squared plus 5x plus 6. We all believe that we can write this expression as x squared plus 5x plus 6 all raised to the power of minus 1. So therefore, in this case, we can also decide to rewrite this expression as, if we factorize this, we end up having x squared plus 3x plus 2x plus 6, right? Then all raised to the power of negative 1. Then the next thing to do from here is to go ahead and um, factorize this to get x plus 3, then x plus 2. This is what you should get. Now, by the time we decide to rewrite this expression, we have x plus 3, x plus 2, and by the time you want to differentiate, it's going to be a very complex one. So I would have preferred we say that this expression is equivalent to this, or at the same time, it is also, this is a negative 1. When you have an expression in terms of negative index, we can write this expression as 1 over, then the expression we have here is x plus 3 and then x plus 2, which is still the same thing. So by the rule of partial fraction, you can decide to solve this by partial fraction, and then we end up having a over x plus 3 plus b over x plus 2. So when you multiply both sides by the LCM, the LCM for these two equations, these two sides, the left hand side and right hand side, the LCM is remain as x plus 3, x plus 2. So I'm actually trying to multiply both sides by the LCM. So I'm multiplying both sides by x plus 3, x plus 2. So if I'm multiplying both sides of this equation by this LCM, this will cancel this. I'll be left with just 1 equals to, then this term multiply this LCM, then x plus 3 will cancel x plus 3. I'll be left with just x plus 2. So I'll end up having a of x plus 2. Then the next thing for us to do here is x plus 2 cancel x plus 2. Then I have x plus 3 left, right? And then from here, we can decide to set x to be equals to minus 3, so that this expression becomes 0. That is, or you say x plus 3 equals to 0. So x is equals to minus 3. So you set x to be equals to minus 3 such that all this second term tends to 0, and then we have just a left. So when I set x to be equals to minus 3, the only thing I'll have left is minus 3 plus 2, that is minus 1, then plus 0. Minus 3 plus 3 is 0. This becomes 0. So then I end up having 1 equals to minus a, hence a equals to minus 1. Done. And since a is equals to minus 1, we need to get the answer for b also. Then we can decide to set x to be equals to any value. Suppose I set x to be equals to 0. Then what happens to b? Then I'll end up having 1 equals to, a is already minus 1. No problem, I'll put that. X 0 plus b, the x I have here is also 0 plus 3. Okay, so a is minus 1. So I have minus 1 times 2, then plus 3b. Yeah, then minus 2 goes to the other side. I have 1 plus 2. That gives me 3, then 3b. So hence b equals to what? Positive 1. So therefore, a is minus 1, b is plus 1. Then we come back to this, our expression we have here before I differentiate. So then we end up having this question given to us is equivalent to a over, and my a is minus 1 over x plus 3. then plus b is what? Positive 1 over x plus 2. So this can be written as, we can decide to write this as minus 1 of x plus 3 raised to the power of minus 1 is allowed. Then this is 1, and I end up having x plus 2 is to the power of minus 1. You know, you have an invisible 1 here, you have power of 1 here, and we can write this as this, and then this as this. So this is what we are going to differentiate. This is our new expression for y. So in continuation, we actually stop here